So let me paint you a picture. You open your laptop, browse a few websites, maybe search for something mildly interesting, close the tab, and think nothing of it. Meanwhile, your ISP has logged every DNS query you made, your browser fingerprint has been recorded by 6 different ad networks, your real IP address is sitting in 3 different server logs, and somewhere a data broker has just updated your profile with 2 new inferences about your political views based on what you read. You didn't do anything wrong, you didn't click anything suspicious, you just existed on the internet and the default configuration, and the default configuration is a surveillance machine that you're living inside of without really noticing. OPSEC stands for Operational Security, and it comes from military intelligence, the practice of identifying what information about yourself you're leaking and systematically cutting those leaks off. In the context of staying anonymous online, it's not one tool and it's not one setting. It's a layered approach where each layer covers a gap the previous one left open. The first layer is DNS, and most people never think about it at all. Every time you type a website address, your device sends a DNS query to translate that name into an IP address, and by default, that query goes to your ISP's DNS server completely unencrypted. Your ISP can see every domain you look up, not the content of what you do on those sites, that's handled by HTTPS, but every single domain name with timestamps. The fix is encrypted DNS, and specifically DNS over HTTPS or DNS over TLS. Cloudflare's 1.1.1 with DOH enabled, Next DNS if you want filtering on top of it, or better yet, run your own unbound resolver locally. This is the lowest effort, highest impact change most people never make. Next layer is your VPN, and I've talked about this before, but I want to be specific about how I actually think about it in an OPSEC context rather than just a privacy context. A VPN shifts trust. Your ISP can no longer see your traffic destinations, but your VPN provider can, which means picking a VPN is picking who you trust with that information. My honest recommendation is what I've mentioned before: run your own. A $5 VPS, WireGuard configured properly, and you've eliminated the commercial VPN trust problem entirely because the only entity that can see your traffic is a server you provisioned. If you're not going to run your own, Molvad is the closest thing to a trustworthy commercial option. They accept cash, they've had their no-log policy verified by independent audits, and they don't even ask for an email address to sign up. But here's what most people get wrong about VPNs in an OPSEC context. A VPN is not anonymity. It's one layer of a stack. Your traffic still exits from one IP address. That IP is tied to your VPS billing or your Molvad account. If your actual goal is genuine anonymity rather than just privacy from your ISP, a VPN alone gets you nowhere near there. That's where Tor comes in, and I want to explain how it actually works before telling you how I use it, because most people either overcomplicate it or massively oversimplify it. Tor routes your traffic through 3 volunteer-operated nodes: an entry node, a middle node, and an exit node. Each node only knows the identity of the node directly before it and the node directly after it. The entry node knows your real IP, but not your destination. The exit node knows your destination, but not your real IP. No single node has the full picture. That layered encryption and routing is what makes Tor fundamentally different from a VPN. The way I use Tor in practice: Tor browser for anything where anonymity actually matters, configured with security slider at its highest setting, which disables JavaScript by default. JavaScript is the primary vector for browser fingerprinting and de-anonymization attacks against Tor users. Disabling it breaks some sites. That's the trade-off, and it's the right one if anonymity is the actual goal. For a permanent Tor routed setup on an entire machine rather than just a browser, Whonix is what I'd point you to, a pair of virtual machines where one acts as a Tor gateway and the other is your workstation, architecturally preventing any application from bypassing Tor even if it tries. Speaking of operating systems, Tails is the one that belongs in this conversation for a very specific use case. Tails is a live operating system you boot from a USB drive. It routes everything through Tor, it leaves no trace on the machine it runs on, and when you shut it down, everything that happened in that session is gone. No forensic artifacts, no browser history, nothing written to the host machine's disk. Browser fingerprinting is the layer that defeats people who think a VPN and private browsing mode makes them anonymous. And I want to spend a minute here because it's underappreciated. Even with your real IP hidden, your browser leaks an enormous amount of identifying information with every request. Your screen resolution, your installed fonts, your browser version, your time zone, your GPU renderer, your canvas fingerprint, the list goes on. Combining these data points produces a fingerprint that's often unique enough to identify you across sessions even without cookies or an IP address. The Tor browser solves this by making every user look identical. Same screen size, same fonts, same everything. So fingerprinting Fingerprinting produces the same result for every Tor browser user. If you're not using Tor browser, Firefox with arcandfox.user.js is the most practical hardened configuration for a daily driver. It requires some setup, but it's documented thoroughly and worth doing. Compartmentalization is the OPSEC concept that ties everything else together. The idea is simple: different identities, different activities, different tools, never mixed. Different browser profiles for different context, different devices ideally. The moment you log into something tied to your real identity inside a session you've been treating as anonymous, the anonymity of that entire session is potentially compromised. This sounds paranoid until you understand how correlation attacks work, combining data points from multiple sources to de-anonymize someone who thought they were clean. Metadata is the thing that defeats people who've done everything else right. You've got Tor running, you've got a hardened browser, you've got compartmentalization sorted, and then you send a document that has your name embedded in the author field, or a photo that has GPS coordinates in the EXIF data, or a file with a creation timestamp that places you in a specific time zone. EXIF tools strips metadata from files before you share them. MAT2 does the same thing with a broader range of file types. These are 2-minute tools that close a gap that has ended actual anonymity operations conducted by people who should have known better. For communication specifically, Signal for anything that needs to be both secure and usable. It's end-to-end encrypted, open source, and the cryptographic protocol it uses has been independently audited multiple times. Use it with disappearing messages enabled. For situations where even the metadata of who you're talking to matters, who sent a message to whom and when, Session removes the phone number requirement entirely and routes messages through a decentralized network. It's a different trade-off from Signal, but the right one in specific contexts. Most people only need a fraction of what I've described here for their actual threat model. The question to ask yourself is not how anonymous can I be, but anonymous from who, for what purpose, against what capability. Your answer to that question determines which layers you actually need. Everything I just walked through is documented across the Tor project's own site, the Privacy Guides website, which is probably the best single resource for this entire topic, and scattered across security research that's genuinely worth reading if you go looking. The information exists. The gap is understanding how the pieces fit together and what the trade-offs of each choice actually are in practice rather than in theory. That's the kind of thinking Cyberflow Academy is built around. Not just here's a tool, but here's why it exists, what it solves, what it doesn't solve, and how it fits into a real workflow. Links in the description.
You still stuck in tutorial hell? We got full courses step by step as well. Web hacking labs, real attack flow. Not click here, actually break the code. Reverse engineering, crack moves inside. Gidra open, ego died. Bug bounty methods that actually scale. Find one vuln, that's grocery money mail. $29, that's it bro. Skill goes up, that's cyberflow. Python for hackers, C plus Spain. Build your own tools like this at home. New course dropping every month. No content drought, we stack it up. Private Discord, killers in chat. Stuck on a bug, we fixed that.